Welcome children to this session. Yesterday we have started this lesson and we have seen some of the concepts like force and its SI unit, effects of force and balanced forces. These are the concepts that we have seen in our previous class children. Today we are going to discuss some more about unbalanced forces, inertia and Newton's laws of motion. As we have discussed yesterday children regarding balanced forces, we have seen there are four types of forces will be acting on even if the object is at rest. If the resultant of all the forces acting on the body is equal to 0, then we call the forces as balanced forces. Today we are going to see about this unbalanced forces. What is this unbalanced forces? Forces are said to be unbalanced when if the resultant of all the forces acting on the body is not equal to 0, then we say that the forces are unbalanced. In this case, remember children, the body will tend to change its position because of unbalanced forces. In the case of balanced forces, the body remains same position. The position of the body doesn't change, but in this case, the position of the object changes. The resultant of all the forces acting on the body is not equal to 0, then we say that the forces are called unbalanced forces. In this case, the body changes its position. Based on this, we are going to look into the next concept, children. That's about inertia. Very important concept, inertia. See, you take whichever the example that you want. For example, an object which is placed on the table. The object which is placed on the table, it will remain stationary until an external force comes and pushes it. Consider the table which is placed in a classroom. It will remain there only until it is pushed by somebody or lifted or shifted by somebody. On its own, it cannot change its position. Consider the planets or the moon that orbits the earth. Planets that move around the sun. They are in continuous uniform motion, children. It will continue to move in its same orbit with the same speed. Unless another aircraft goes and pushes it or blocks its way, it will continue to move. Therefore, if the object remains at rest, it will continue to remain at rest. If the object is in uniform motion, it will continue to remain in its uniform motion until which time? Until an unbalanced force acts on it. This is about inertia, children. Tendency of a body to remain in its state of rest or uniform motion unless an unbalanced force acts on it. If an object is at rest, children, it will remain at rest. If the object is in uniform motion, it will continue in its uniform motion. Till what time? Unless an unbalanced force acts on it. So, in this, inertia of a body depends on important concept, children. This one, inertia of the body depends on mass of the object. Consider two vehicles, a bicycle and a car. Inertia of a car will become more due to its mass. This is the concept regarding inertia. This concept is important because Newton's first law is based on inertia, children. There are a number of situations we can take. Okay, the example of inertia. If we look into types of inertia, there are three types of inertia, children. Inertia of rest, types of inertia. First one, inertia of rest. What is that inertia of rest? If an object is at rest, it will continue in its state of rest unless acted upon by an unbalanced force. Second case is inertia of motion. Inertia of motion. If an object is in uniform motion, it will continue in its uniform motion, state of uniform motion, unless acted upon by an unbalanced force. The third one will become inertia of direction. The object, if it is in motion, it will move in a particular direction unless it is acted upon by an unbalanced force. Unless an external force acts on it, it will not change its direction. These are the three types of inertia. Regarding this, you will study more about in your higher classes, children. Just you have in your 9th standard about inertia, and inertia of a body depends on what? Based on that, we are going to study about the Newton's 3 laws of motion. Regarding Sir Isaac Newton, he was born in 16th century in England. He was a physicist and a mathematician. One of the modest scientists of all the times. He studied the ideas given by Galileo regarding force and motion of objects. To describe the motion of objects, he suggested the 3 laws of motion called Newton's laws of motion. We are going to study about this in this session now. Now, we will see what is about Newton's first law of motion. This Newton's first law of motion is also known as law of inertia, children. Because inertia we have seen, tendency of a body to remain in its state of rest or of uniform motion unless acted upon by an unbalanced force, which means if the body is at rest, it will continue to be at rest. If it is in motion, it will continue to be in its state of motion unless an external force acts on it. The same which is mentioned particularly in this law. Therefore, this law is also known as law of inertia. He was one of the most influential scientists of all the times. He has given 3 laws in order to study the motion of objects. The first law says, an object remains in state of rest. An object remains in a state of rest or of uniform motion along the straight line unless acted upon by an unbalanced force. If the object is at rest, it will continue to be at rest. First point. If the object is in uniform motion, then it will continue to be in its uniform motion along a straight line. This is an important point to remember. If it is at rest, it will remain at rest. If it is in uniform motion, it will continue its uniform motion in a particular direction, the same direction, unless acted upon by an unbalanced force. This is regarding Newton's first law. This is about. You have to learn this Newton's first law. Examples of Newton's first law. There are a number of day-to-day life situation examples can be taken for Newton's first law. The first one, imagine that you are sitting in a car, suddenly it moves with a greater velocity. Suddenly it moves with a greater speed. We tend to fall back. Then you are the second example. Remember, imagine that you are in a car, it moves with a greater velocity. The driver suddenly applies the brake, then we tend to fall front. Okay, nobody pushes you. When the car travels with a particular speed, we too will be traveling in that speed, but car has comes to rest, but we travel in the speed, therefore we tend to fall front. Okay. Then the third example can be taken. When a branch of a tree is shaken with a force, the leaves tend to fall. Okay, these are all the examples of Newton's first law of motion. Regarding Newton's second law of motion, Newton's second law of motion gives the relationship between force, mass and acceleration. The statement goes like this, children. The acceleration produced in a body is directly proportional to the force applied and inversely proportional to the mass. Let's see how these things. Children, regarding Newton's second law of motion, it's another easy law to understand, children. Let me take these two illustrations to explain Newton's second law of motion. See, there are two cases that you need to understand in this, children. This law builds a relation between force, mass and acceleration. This is the first case. This law gives the relation between force, mass and acceleration. Let's see how this. There are two cases I have taken. Consider the first case. Same amount of force, that's about one is 5 Newton and 10 Newton. Not the same amount of force. Different amount of force is applied on the same vehicle. Imagine when acceleration takes place, when there is change in the velocity of an object, acceleration takes place. When 5 Newton of force is applied on a bicycle and if 10 Newton of force is applied on the same bicycle, in which case acceleration produced in the cycle becomes more. This is the first case. Force is less, force is more. When force is applied on an object, velocity changes, acceleration is produced. In which case more acceleration is produced? Obviously in the second case, because more force is applied on an object. If force is more, the acceleration which is produced in the vehicle becomes more. This is very clear, children. Case 2. Same force I have taken, but different objects. One is a bicycle, another one is a car. Same amount of force is applied on both the objects. In which vehicle acceleration will become more? Obviously, acceleration will become more in this bicycle because whose mass is less. Remember, children, mass becomes more. These are the two concepts, children. Listen. The statement says, the acceleration produced in a body is directly proportional to the force applied. The acceleration which is produced in the body directly proportional to force applied. This is first part. Okay, if the acceleration becomes more, then the force applied should have been become more. They are directly proportional. If one quantity increases, other quantity also increases. We call that as directly proportional. If force applied becomes more, the acceleration which is produced in the object will also become more. That's the first part. Acceleration produced in a body is directly proportional to the force applied. Second part, acceleration which is produced in the body is inversely proportional to mass of the object. If the mass is less, acceleration which is produced become more. We have seen in this case cycle and a car, in which case acceleration produced more on cycle. In cycle, acceleration produced becomes more because mass is less. Therefore, remember children, we say inversely proportional, which means if mass is less, acceleration becomes more. If mass becomes more, acceleration becomes less. We say it is inversely proportional. If one quantity increases, other quantity decreases. If one quantity increases, other quantity increases, directly proportional. This is inversely proportional. Looking at these two statements, we can say this law. Acceleration which is produced in a body is directly proportional to the force applied and inversely proportional to mass. Combining these two, we can write like this, children. Acceleration is directly proportional to force applied and inversely proportional to mass. Now, by cross multiplication, m comes here. M into A proportional to F. This is nothing but F proportional to M into A. Let me take out this proportionality sign and place a constant K into MA, where this K to be considered as a constant value of 1. Therefore, this equation becomes, children, F is equal to M into A. This is another important formula that we need to remember when we work out problems based on this force, mass and acceleration. Therefore, children, in the beginning of this statement what I have said, this law gives the relationship between force, mass and acceleration. Force, mass and acceleration. The acceleration which is produced in the body is directly proportional to the force applied and acceleration is inversely proportional to mass. Combining these two, I have taken by cross multiplication. This proportionality symbol is taken out, therefore K is placed. K is said to be a constant whose value is 1. Therefore, F is equal to M into A. This is about Newton's second law of motion, children. It is easy one. Don't try to by heart, children. Understand this using the illustrations 1 and 2 that I gave. The acceleration produced in the body is directly proportional to the force applied and inversely proportional to mass of an object. Regarding Newton's third law of motion, this is another easiest law of motion which you have studied in your lower classes, children. To every action there is an equal and opposite reaction. The situation can be seen in many of the examples. Two examples just I have given, children. One is launching of a rocket. The launching of a rocket, all of you might have seen. Okay? During the launching of a rocket, the exhaust gas released from the rocket with very high velocity. That becomes action, because of which the rocket flies in the opposite direction. That becomes the reaction. The release of exhaust gas is the action. The flight of a rocket in the opposite direction is the reaction. Person swimming in a pool. All of you might have seen or observed or felt, when we push water, we exert force on water, that becomes the action. The force exerted by water on us becomes the reaction. Therefore, we tend to fall forward, move forward. These are the two simple examples that I have taken, children. This is the easiest law. To every action, there is an equal but opposite reaction. So these are the three laws we have seen, children. Learn them, write them in your notes neatly, children. Refer the textbook. Then in the remaining classes, we have to look into another concept called momentum. Then solve or proof of Newton's second law in terms of momentum. We are going to see in our next class, children. Thank you. Have a nice day, children.